All right, question 10. 70% of pregnant women have morning sickness in the first trimester, the first 3 months of pregnancy. Suppose we randomly select 20 women who are or have been pregnant and asked if they experienced morning sickness. Determine if the setting is binomial, geometric, or normal. This could be a binomial because we have, you're either going to be pregnant or not pregnant. Or independent events because you only had 20 women, and out of all pregnant women, that's a very small chunk, so we can assume each probability is going to be roughly the same. We have a set number of trials at 20, and we are talking about a probability of success being 70%. So all said and done, our binomial is binary, independent, normal, set number of trials, and the probability of success is 0.7. So we have a couple ways to do binomials. Okay, binomials, you're going to do the binomial constant times the probability of success to the power of how many successes you want, multiply by the complement of that times the remaining. We don't typically use that. I like to use Binomial Pdf for an exact amount. So what you want to do on this is find probably exactly 12 have experienced morning sickness. You're going to go into your same menu your normal is. Do second vars, binom PDF. Your trials would be 20. Your P is your probability. And your X value is 12. And so that exact amount would be about 11.4%. So probability that exactly 12 have experienced morning sickness is 0.1144. C, find the probability that at most 12 have experienced morning sickness. Well, at most 12 is the same as 12 or less, but it's including all the ones before. So you have to do the binomial CDF. So you're going to have your 20 again, your 0.7. Your X value is 12, but what this is doing is doing 12, 11, 10, 9, 8, 7, all the way to 0. So it's going to be more, and that's 0.227. And then finally for D, probability that at least 12 women have experienced morning sickness. At least 12 is greater than or equal to 12, which is the complement of 1 minus less than or equal to 11. So what we want to do is we want to do binomial CDF. $20.7, do 11, and that's going to count everything at 11 or below. Then you're going to subtract that from 1. So that probability is about 88.66%. So you can see the differences there and how you interpret those. All right, next question, talking about mean and standard deviation. We didn't get to that in class, but here's some formulas on your formula sheet. It's pretty straightforward. You just plug them in. So the mean of a binomial distribution is the number in the distribution times the probability of success. Standard deviation is the square root of that same number times the complement. So literally, to get that mean and standard deviation, here's what you're going to do. You're going to take your, since this was 20 successes, probability of success is 0.7, you're literally just multiply those, you get mean of 14. Standard deviation, you're going to do your 20 times your 0.7, but then you have the complement of that, so that's going to be 0.3. So these two probabilities got to add to 1, and so you're going to get 2.05. So in a binomial distribution, they can have means and standard deviations. That's how you get them. We'll skip letter F.